survey and some other resources for looking at the soils data that we've been talking about. Okay, so the first thing I wanted to show you guys is our soils, or NRCS Wisconsin soils homepage. And on that homepage, there's a variety of tabs that you can select and look at some of our resources. For those of you within the state, you probably get my weekly updates that are more like every other week or every third week. But those same tabs are usually in that email. And the one we're going to talk about the most today is this tools tab. But definitely check out some of the other ones, like the soil health tab. There's some really good success stories and resources related to soil health. And then there's other ones related to like land judging and soil judging, contact pages if you're looking for a soil scientist in your area. So definitely check out this. It will be in the list of links we provide at the end of the training, but mainly I'm going to focus on the tools section and show you guys how to access some of the data and create pretty little figures like the ones on the right. So the first thing I want to point out is that when we talk about soil survey, we have two main products that are available for you. There's the SurGo data, and then there's StatsGo. So SurGo is what you guys typically look at when you open Web Soil Survey and pan around or look at a specific area. It's our detailed soil maps. As Jeremy explained, in Wisconsin, we mainly have Order 2 soil maps, which are designed mainly for like 1 to 12 or 1 to 20,000 scale. And then there also is this database called StatsGo, and that's our general soils map. So if you're looking for like a soils map for the whole entire state, StatsGo is what you're going to want to use. You can get that through Web Soil Survey. I didn't include instructions on how to access that, but if you just Google StatsGo and have any issues obtaining it, let me know and I can help you look into that. So we have these two products. The one I'm mostly going to talk about is SurGo from now on. And then in the future, we'll probably see this at some point. A lot of the soil survey division folks are working on creating these digital soil survey products. So this example right here, you can see the SurGo lines, the yellow or the white lines indicating different soil map units. Well, with new technology and modeling capabilities, we can actually predict where soils occur at a much finer scale and use pixels to differentiate different soil types rather than these clunky polygons that we've been using since whatever 1901. So I think in the future, at some point, we're probably going to be using products like this where they're pixelated maps. So I just wanted to show you of what one would look like. And but at the current moment, we don't really have a good repository for storing this information and making it accessible to people. So for now, we're going to just rely on those polygon products, the vector products. And the really cool thing about how these are made is you pretty much go out and collect a bunch of training data. So you'd go out and dig some soil pits in really precise landscape positions or using a random sample data set. And then you use a stack of different geospatial data like elevation maps, slope maps, geology maps. And you pretty much feed that all into a computer and it will predict where all of these different soils that you named when you collected your training data, where they occur, and you can create this this model that you can then adjust. So we do have staff in Wisconsin that are working on some of these products, but like I said, they're hard to obtain and we really don't have a repository for them. So these are some of the apps you can use to access soil survey data. The one I'm mainly going to talk about is the Web Soil Survey, but I really like the SoilWeb apps. The ones that are developed by UC Davis and the NRCS, they're really great if you're just trying to pan around and look at a location. There's even a phone app that you can get on an Android or an Apple phone. There's even a way to stream that SoilWeb service into Google Earth if you like using Google Earth. And then there's these other data sources such as the Geospatial Gateway. If you're a GIS wizard, you can go download data directly from that gateway. And there's other stuff there as well, like DMs and imagery and stuff like that. I don't really explore the Geodata Gateway as much as I should, but it definitely is like an official repository for getting soils and other data. There's also this database called the Official Soils Description Database, which I'll talk about in a little bit. That's a good place if you know the name of the soil that you're interested in and you're just trying to look at like the broad range and characteristics that soil has. Definitely check out the OSD database. Series Extent Explorer, that's a way if you just know a soil and you want to see where it occurs throughout the state or throughout the country, you can look at that Extent Explorer. And then finally, the Soil Lab Data Mart. That's really cool if you want to look at specific measured laboratory data associated with the soil. So there's a query database where you can query soils by their name and look if we've sampled and collected any laboratory data for that soil. And I will definitely talk about that a little bit more too. But like I said, we're going to focus on Web Soil Survey today. So like I said too, the SoilWeb is a really great resource for panning around. You can see my hand holding a phone right there. That's what it kind of looks like when you pull it up on your phone. It really doesn't give you the map, but there is a link when you open it on your phone that you can click and it will pull up the SoilWeb web link, which I have below, and then you can access the map. But most of the time, if you're in the field, that's kind of clunky, so you're just going to get these profile plots that show what map unit you're standing on. Definitely a really good resource if you're just trying to look at a location or show somebody somewhere really quick, because with this you really don't have to define an area of interest, which you'll find out is kind of tedious in Web Soil Survey. This is my favorite link for looking at soils data. It's called the Soil Data Explorer. So I mentioned that OSD database, the Series Extent Explorer. This Soil Data Explorer has all of that built into one web interface. And at the top of the web interface, you can see those different tabs like the OSD, the lab data. It's got all of that stuff right built in there. You just type in the series name and it pops up and shows you how many pedons have been collected for that series. It shows you those black and white block diagrams that show where the soil occurs in the landscape. And then for the more technical people that want to get nitty gritty into soil taxonomy, it even shows you the relationship between the classification of that soil and other soils that are used in that MLRA or in that county. The Soil Lab Data Mart, that's where you query our lab results. You can see where all of these samples have been collected in Wisconsin. We're continuously sampling soils every year. It takes a long time to get the data back, but it's really intensively collected data. We measure almost anything you could think of related to soils for each horizon. And the cool thing about this, if you like to code or you like to get down in the data, you can summarize this with all this really neat code. So look over on the right, you'll see some figures where I colored each soil horizon using their actual color that was recorded in the field. And then below that, I used the actual pH measurements to color the horizon. So you can see for our state soil, there's a big range in pH near the surface. And that mainly has to do with what Kristen and what Jennifer talked about and how that property is dynamic. So this is really useful if you want to just look at like what is the actual measured range that we've recorded for these soils and not what just our predicted range or what's populated in our soil survey data is. And then down at the bottom, that's another type of plot you could create showing these properties and how they change with depth. So these are comparing 3 different soils, and it's hard to read, but on the left side of the graph, there's clay content. In the middle, it's cation exchange capacity, and on the right, it's base saturation. And you can see how these soils are different, especially in the clay contents. So it's really fun to play around with this data. It's kind of complicated, but if you guys have any questions, you know who to ask. But let's get into Web Soil Survey now. So this is our official repository for using soil survey data. It's what landowners use, real estate agents, universities, almost anybody that utilizes soils data is probably dabbled into Web Soil Survey a little bit. And there's 5 tabs at the top, and I'm going to go through each tab sequentially. This is the homepage. I definitely recommend if you are new to soil survey, check out the homepage. Look at some of these resources. There's basic steps that will run through how to use it if you don't absorb what I'm talking about today. There's also some of these links to the other databases that I mentioned, such as the Geodata Spatial Gateway, the official data or official soils description reports, Soil Extent Explorer, and whatnot. First, I like to show people if you're in Web Soil Survey, there is a way to go and track down that original soil survey publication. I find these really useful, especially for counties that you're unfamiliar with. If you just want to learn the general soils in a county, go back to that original publication and just read the preface, and you'll learn a lot about the geology, about the land use, and about the soils there. Somebody told me, I think yesterday, that their previous supervisor told them whenever you're working in a new county, figure out what the top 10 most common soils are and memorize what they are, because that will help you understand everything else. So to view that, if you look at the top of the Web Soil Survey page, there's a tab called Archived Soil Surveys. You just click that, it will bring you to this web page, and then you can scroll by county and get the original publication. We also have paper copies in the state office. I'm sure a lot of the field offices have them too. I like to bring those out for outreach events and whatnot. So after that, we'll just focus on these next tabs. So when you go into Web Soil Survey, the first thing you're going to have to do is define an area of interest. And there's multiple ways to do that. You could skip that process and just download all of the soils data for your entire county. That's that red arrow on the right. You would just skip to that tab. But for now, let's just talk about this area of interest, and I'll get down into it in a little bit. So you can see the options there. You can do it by county, by soil survey area. There's different Forest Service units, hydraulic units. Most people are either going to import an area of interest from a shapefile, which is a file you would use in a GIS environment, or they're going to manually draw it using one of those tools shown in the right yellow arrow. So if you did skip and go to that download soils data tab, this is what it would look like. You can search by your county or by your county area symbol and then pull that data up in a zipped downloadable link file and then open it directly into ArcMap. So some of you guys might want to know how to do that if you like using ArcMap and you're going to be working with your whole county's data. But for the most part, from now on, we're going to talk about the other options. So one cool thing on our soils homepage too is that you can just select a soil survey area from there directly too. So down in the right, and I'm going to give you all these links so you'll have them, but down over there on the right, you can see you can select Adams County, Wisconsin, select soil survey data, direct area of interest, and it will link you right to Web Soil Survey and have that area of interest defined. But like I said before, you're mostly going to probably use that manual way of delineating your area of interest, which are indicated by those two symbols with the red arrow. And you can either do it by a rectangle, like I did in this example, or you could do it by a polygon where you would have multiple vertices. Importing shapefiles. This is a question I get a lot from people because it is confusing with Web Soil Survey. So right here, I have ArcMap open and I've delineated an area in the driftless region that I wanted to use in Web Soil Survey. I saved the shapefile in a folder on my C drive, and you can see if I open that folder in the File Data Explorer, it's actually multiple file types. A shapefile is a pretty complicated piece of data. There's a projection, there's a shapefile, there's a database file, there's all these different files that when we open it in ArcMap, it's just one thing, but when we open it in a folder in our File Explorer, it's all of these different files. So it's really important to note when you're emailing somebody a shapefile, make sure you put it in a folder and zip it up before you email it to them. And it's the same with Web Soil Survey. You can either zip the folder and import it that way, or like on this slide, you can identify each one of those different files. So look over on the left in that column and you can see there's multiple files selected from a folder on my C drive, such as that shape, the projection, the database. And right under that, there's also another option for creating an area of interest from a zipped shapefile. That is what I recommend. If you're going to import a shapefile and use it to create an area of interest, just put it in a zipped folder and import it that way. And that way you don't have to select each one of these individual folders and somehow get them mixed up. Last, you can also export an area of interest for future use, which is very useful because when you start using Web Soil Survey, you'll realize that it will time out after a certain number of minutes. So a lot of times, like, you delineate your area of interest perfectly, and then you go out for lunch and you come back and it says your Web Soil Survey is timed out, and then you have to re-delineate that area of interest. So learn how to export them. Even if you don't use ArcMap, then you could re-import it once again. And somebody asked, can you import a non-contiguous shapefile? And that is definitely, I believe, possible, unless somebody can correct me. Okay, so once you delineate that area of interest, or you look at your whole entire county, your whole soil survey area, the next tab is going to be your soil map. So this is what the soil map looks like. You can see it's really hard to view the symbols at the scale that I have set up in this size of an area. If you did want to change the size of these symbols, you can see there's that little legend tab. If you just open that up and right click the soil survey map units, you can change the symbols so they're a lot bigger, and you can even change the color of the lines that are delineating each individual map unit. What you can do from this soil map tab is look at the individual map units. If you notice, they're hyperlinked in that blue text for each map unit name, and you can click it, open it up, and it will tell you what components occupy that map unit, what their landscape position is, what the map unit attributes are, like elevation ranges, frost-free days. It gives you a pretty good idea of the general characteristics of that map unit and the soil components in there. So very useful. When you check out your data and you produce a report, all of this will be in there usually. The things that I find probably the most useful are looking at the components, the typical profile. I like looking at things like forage suitability groups, whether the soil's hydric or not, and then what landform it's on. I think that is the most useful thing to me. Once you understand what the soil looks like and what landform it's on, you don't even need the map. You can just walk out on the landscape and say, oh, this is a terrace, this is a floodplain. I expect to see that soil on the terrace and this one on the floodplain. Think about scale with our mapping. It's very broad. It's like a geology map. If you understand the soil landscape relationships, you can map anything to a first order on your own. And you don't have to really be a soil scientist. All right, the next one is this Soil Data Explorer tab. So this is where you're going to look at interpretations, soil properties, and soil reports. And it's really hard to find things. I'm going to show you a trick at the end using the search bar. There's so many different interpretations, so many different properties, all these reports. Sometimes I get them mixed up. It's hard to find, but you can always use that search bar and use you can use keywords to find different things. Related to soil health, there are some interpretations in Web Soil Survey, such as the soil susceptibility to compaction or organic matter depletion. Those are really good interps to look at, especially if you're having issues with CART, because these are the same interpretations that are used in CART, and this will kind of explain more why it's interpreting that way. If you guys remember on the presentation I gave earlier, when you look at an interpretation, you can look at the data in a tabular format and see why it was interpreting a certain way. And then you can start to think, does that make sense based on what I saw in the field? So related to soil health, the ones that I think are useful are going to be right in that soil health folder under suitabilities and limitations, but also just recognize that there's also other tabs such as soil properties and qualities, and then that soil reports tab. So this is what the soil properties and qualities tab looks like. You can see there's a lot of different ones. What I have opened up is the physical properties, and I'm mapping just organic matter. I'm going to talk about aggregation techniques, but if you look over on the left, you can see that for things like organic matter, you have to specify how that data is aggregated. What depth are you looking at? Are you just looking at the surface like I am here? So it's a little bit more complicated than just clicking view rating and then looking at the data. So I just mentioned this, aggregation methods. This is really complicated, but really important. So we have these map units, and they're composed of multiple components, like this example I have over on the right, which is a complex. Jeremy explained what type of map unit that was earlier. So you have these different soils, but we also want to look at the data spatially, and we only have one map unit. So what value do we use to symbolize that map unit is really important. Do we take the dominant component? I don't know how to say that one right there, but there's 55% of this one soil. Do we just want to map that in our map, or do we want to take the most limiting component, like that hydric soil? So it's really important to consider how the data is aggregated. So dominant component, pretty obvious, you're going to take the component with the highest percentage. Dominant condition, it's going to compare all of those components and say, what's the most common value shared between them? Like say, for example, you wanted to map the landform. All of these soils are on floodplain, so it would come out as floodplain. Minimum or maximum, that's going to apply to numerical data. Say you wanted to look at the maximum soil organic carbon in that map unit, or the minimum, that would be useful for there. Weighted average, it's just going to weight the values based on their component percentages. And then, like I said, that limiting component is often used, especially for things like hydric soils, where you want to pick the most limiting. A good example of that would be like the most susceptible to compaction. So we've gone over the suitabilities and limitations for use, that tab that's under the Soil Data Explorer. We've gone over the soil properties. I can't go over every single property, every single interpretation, but I can show an example. So I tried to. I can show you guys my favorite interps, my favorite properties if you want to contact me. But last, I just want to talk about this soil reports tab. So the soil reports tab is very similar to the properties and suitabilities, where it produces this tabular report, but it doesn't produce a thematic map. And honestly, this is probably what a lot of you guys are going to utilize for conservation, things like grass waterway design. You're going to go in and you're going to find that engineering properties soil report, and it's going to provide you everything you need. And that's the one I have open here. You can see it provides that hydrologic soil group. It provides you information about each horizon, like the texture, the engineering particle size classification, the liquid limit, the plasticity limit. I know Adam's going to talk about some reports he uses for grazing in the next module, and then also Josh should talk about some that he uses or thinks are important for conservation planning. I just wanted you guys to know that there's these reports in there as well, and they're kind of different than those other two tabs. One thing I'll also point out here, I don't know if I have it on a later slide, is if you look in the top right, what you can do is if you're looking at this report and you just want to print it out or save it right away, you can click that little button that says printable version and a PDF will pop up. Or if you're going to have multiple reports, a lot of thematic maps, the soil map, and you're going to compile this all into one thing, just click add to shopping cart and it will add to your list of properties or of reports that you're going to print out later on. So download soils data tab. That's really important if you're going to use this in ArcMap, because what's really cool about it is you define your area of interest and then you can export that all and look at those thematic maps in ArcMap and save them for later use. So we already showed this tab in the beginning really quickly, where I showed you how to download the data for your whole entire county. This is where you would download it based on your area of interest as well. I just really quickly wanted to go over using some of this data in ArcMap. It's a little bit complicated. When you open or when you download that data, it will come with a folder containing the spatial information, and then it will contain a folder with the tabular information. The tabular is all those tables that you create through reports and interps, and then the spatial data has the thematic maps, the soil maps, and then point and line features if any of them exist. And this folder that I have right here, when I opened ArcMap, it gave me the option to add whatever those products I wanted to. I added the soil map, and you can see when I open up the attribute table, all that's in that soil map is a list of all the polygons and their map unit symbol and something called a map unit key. That map unit key is really important because what it is used for is linking that spatial data to all of the tables that you have in your tabular data file. And there's a specific process to do that you can only link map unit keys that are in the same integer format as they are in the text file that's in that tabular folder. So you might have some issues. Like I said, ever having problems with this, contact a soil scientist or a GIS specialist, and they will know how to do this. So in this example, what I did was I linked the map unit table that has the map unit name, the symbol, all of that, the type. I linked that to the spatial information. Okay, so I'm going pretty quick. I don't think you guys will complain if I'm done a little early, but here's the shopping cart tab, and this is where you're going to download all of those reports that you added to your shopping cart, and the output is going to be a PDF. So you can select a delivery method when you hit checkout in the top right. You can toggle on and off what things you want in that report. Like say you didn't want the soil map in the report, you could uncheck that box down in the table of contents on the left. And then there's also some options such as printing it in a landscape versus a portrait mode, or giving it a title or whatnot. So once you have your soil map, the interps, the soil reports you want, you add each of those to your shopping cart, and then at the end you check it out or you save it for a later date. And this is what the output would look like. You're going to get the title page. It's going to give you information of how that soil survey was conducted, those map unit descriptions I showed you, and then any custom reports, the soil maps, and the thematic maps that you added to the shopping cart. All right, now I just have like 3 helpful hints. So I've been mentioning this over and over because I told you guys I've been using Web Soil Survey for almost 10 years, and I just learned about this last year, that there's a search bar so you can find reports and interps. And so you can use keywords. In this example, I was looking for that hydric soil rating by map unit report or interpretation, and you could see I just typed in hydric into that keyword, and look what popped up, the interp that I was looking for. Another one is I mentioned is changing symbol sizes and preferences. So there's that little tab right next to the map says legend. You can open that up and see what's in your map. And if you just right click whatever it is and hit edit layer properties, a window will pop up and you can change the label size, the boundary colors and widths. Also, if you look way at the top of the page, it says preferences. You can also adjust the preferences of the interface. You can adjust the color scheme, the size of the text. That was another thing I didn't know about until now. Last, I'm going to talk about this other helpful hint, which is identifying point and line features. And honestly, you can use this identify tool for a lot of different things. So if there's ever something in your map, there's that blue symbol, you can use that to figure out what it is. So an engineer who's actually in the cubicle next to me right now came to me the other day and says, what's this thing popping up in my soils map? You can see there's a line cutting through a manure storage lagoon that says SLP on it. So what I did was I showed her how to use that identify tool. She clicked the SLP and this window popped up and it told us what that was. It's a short, steep slope. So back in the day and even today, sometimes we use point and line features while we're conducting soil surveys to identify unique observations. Over on the left, you can see a list of different point features that somebody would use, such as a sinkhole, a gravel pit, a wet spot. Some soil surveys utilize these point systems and some others didn't. And then there's also special line features, and I honestly don't know all of them, but they're things like gullies, steep slopes, rock outcrops. They can be identified with that identify tool. While I'm here, I'll also just talk about some of the other tools that are up there near that big arrow. You can zoom in and out. You can pan around with that hand. The little globe will zoom out all the way. The little globe with AOI will zoom out to your area of interest. That blue arrow will go back to your previous extent. I usually find that very useful. If you zoom in by accident too far and want to just go back, just hit that blue arrow. Then you have the identify tool, then you have the measure tool, and then this last one, I actually forget what it is. So sorry about that. You can explore that on your own. All right, that's it. So anybody got questions? Anybody want me